Hey students, I hope you are all prepared for the exam tonight, a couple of hours from now. Today we had an interesting situation here in the lab that I thought I would share with you that might be pertinent for your exam today. Ping Shishu want to do some experiments with lysine hydrochloride, and he asked James Liu to order that reagent. They ordered last week, and today the reagent arrived, and instead of lysine hydrochloride, as Ping Shi has asked for, came today lysine dihydrochloride. So they start to have an argument, and the Ping Shi wants to do this experiment today by all means. And I said, okay, we have a way out of that. So let me explain to you exactly what happened today. So again, Ping Shi wanted lysine hydrochloride, and in the mail today it comes, instead of lysine hydrochloride, came lysine dihydrochloride. So how we can work to make this thing be useful, and instead of order a new reagent and wait for next week for lysine hydrochloride to come. So here's is the difference, okay? So lysine hydrochloride has only one HCl attached to it, okay? Only one chloride is a counter ion there. And the lysine dihydrochloride has two HCl attached to it. This letter is very faint in here. Let me rewrite what comes in here. HCl and the two HCl associated with that molecule. So let's first of all, let's write the structures of lysine as we know. Okay, so we always start with the most protonate form of the amino acid, which in this case here would be COOH, CH, NH3 plus. And here we have CH2 that you can write for simplicity CH2 NH3 plus. So this here would be the form of lysine with two positive charge, lysine plus, 2 plus actually, 2 plus. And if you were to titrate this with potassium hydroxide or sodium hydroxide, we know that the first proton that will go away would be this one. So we would have COO minus CH NH3 plus CH2 4 times NH3 plus, right? So right now we have then the charge for this is going to be, we have a positive charge in here. Why don't I write this NH3 plus up there so that it becomes a little bit more clear. So we have the charge NH3. So we have the charge here, positive, negative neutralized, and the positive here. So this is the version of lysine plus. So what Ping Shi wants is lysine plus, and what ended up in his hand was lysine 2 plus. Okay, so this dihydrochloride means that there's two chloride associated with that. So you have to have 2 chloride anions. Has to be, the charge has to be positive 2, right, to counter the ion, right? If you have lysine hydrochloride, only one chloride, then we have to have only one positive charge. So they have this problem, and they said, what do you want to do? They said, well, we want to make 1 liter solution of 0.1 molar of lysine hydrochloride. And I said, okay, let's do that. So we have lysine hydrochloride 0.1 mole here. We didn't have lysine hydrochloride, we have lysine dihydrochloride. We get the molecular weight. That it would be a given in a problem, for example. The molecular weight for this is 219.1 grams per mole. And they want to make 0.1 molar solution in 1 liter, so the number of moles is going to be 0.1, right? So the amount of mass that they are going to need is 21.991 grams of this lysine dihydrochloride. Lysine dihydrochloride, okay, dihydrochloride. Dihydro, that's simplicity here, all right? So 21.9 grams of this reagent. However, this is not the isoform that Ping Shi wants. This is going to be lysine 2 plus, and Ping Shi wants lysine plus. So what do we do for a situation like that? We just titrate. We just titrate and push this lysine 2 plus to lysine plus, and he's going to have his reagent today, and he's going to do this experiment later this afternoon. So how do that? What's the number of moles that we have here of lysine dihydrochloride that we prepared the solution? The number of moles is going to be given by the molarity times the volume in liter, right? So the number of moles, the molarity was 0.1 and the volume was 1, so the number of moles was 0.1 mole. So we have 0.1 mole of this form of lysine, and we want to make 0.1 mole of this form of lysine. How much hydroxide we need for that? We need 0.1 mole of hydroxide. I look around, just behind there was a solution of sodium hydroxide, 0.5 molar. 0.5 molar. So I said, okay, let's use this sodium hydroxide, but how much do we need of this sodium hydroxide to pull this thing together? So we want the number of moles of sodium hydroxide to be 0.1 mole, right? So I have the molarity of the solution is 0.5. Therefore, I know that molarity is number of mole divided by volume in liter. Just to refresh your mind about those formulas. And then the volume in liter here would be the number of mole divided by molarity. The number of moles in here that we want, 0.1 mole. The volume that we want, 0.5. This is 1 divided by 5. This is going to give 0.2 liters or 200 milliliters. All right? So how do they solve this problem? How they go about it to make this solution? Get a little more space in here. They will pick up any glassware in the lab that is good for this thing. And they'll put a little bit of water, let's say 500 milliliters of water. Then they would add 21.91 grams of lysine dihydrochloride. So lysine dihydrochloride. Right? And finally, they added 200 milliliters of sodium hydroxide slowly. 200 milliliters of sodium hydroxide. The solution of sodium hydroxide was 0.5 molar. And now, finally, they adjust the final volume to becomes 1 liter. So let's adjust in here. Adjust the volume to 1 liter. So Pinkishi has his solution today, and you knew how to do that because by now you have memorized all these isoforms of amino acids, and it is very interesting kind of question, correct? If not, it's still time to go a little bit faster and look at these different isoforms. So again, hydrochloride, it means only one chloride, so that the formula of the amino acid has to be positive charge 1. And if it's dihydrochloride, so that means 2 chlorides, so the other form has to be 2 plus. Very simple problem, and it happens in the daily life in the lab, and I thought I would share with you together with my good wishes for a good exam tonight. See you very soon. Bye-bye.